Today, we will be discussing about speed, distance, and time, a topic which is very often seen in the different competitive exams, whether it be the bank exams or CAT or GRE and other relevant competitive exams. So, we will be solving some based on those competitive exams from the chapter Speed, Distance, and Time. The first question that we will be discussing today is a man travels 35 km partly at 4 km per hour and partly at 5 km per hour. If he covers former distance at 5 km per hour, he could cover 2 km more. The time taken to cover the whole distance at original rate is, these are the options. So let us see how we solve this sum. Solution. Let x kilometer be covered at 4 km per hour. So 35 minus x kilometer is covered at 5 km per hour since the total distance is 35 km. Time taken to cover x kilometer equals to x by 4. Similarly, time taken to cover 35 minus x is 35 minus x by 5. Therefore, total time equals to x by 4 plus 35 minus x by 5. So we get the LCM as 20 and 5x plus 140 minus 4x, which is x plus 140 by 20. So the total time that is being taken to cover the distance partly at 4 km per hour and partly at 5 km per hour is x plus 140 by 20. Now we know that time into speed gives us distance. So this is the time. If the speed would have been 5 km per hour as per the question, if he covers former distance at 5 km per hour, he would cover 2 km more. 2 km more means the total distance that will be covered would be 37. So x plus 140 by 4 is equals to 37. X plus 140 equals to 148. X equals to 8. Therefore, total time required at original rate. So we just substitute the value of x in the equation, which will make it 8 plus 140 by 20, which is 148 by 20, which is 7.4. So my answer would be 7.4 hours. The second question that we will be discussing today is, a man takes 7 hours in walking to a certain place and riding back. He would have gained 2 hours by riding both ways. The time he would take to walk both ways is, these are the options. So, while solving this sum, let the person take x hours to walk and let the person take y hours to ride. As per the question, his total time that he's taking to walk and ride is x plus y. So from the first condition, a man takes 7 hours in walking to a certain place and riding back, we get x plus y equals to 7. He would have gained 2 hours by riding both ways. That means if he would have ridden both ways, that means time would have been y while riding to that place, and y, while coming back, he would have taken 2 hours less. So we would get 2y equals to 5. Now if I multiply the equation 1 with 2 and equation 2 with 1, we will get 2x plus 2y equals to 14 and 2y equals to 5. That means if we subtract, we get 2x equals to 9. So 2x equals to 9. That means if the person walks both ways, he would take 9 hours. So the answer here would be none of these. The third question is, A, B and C are on a trip. A drives at 50 km per hour for 1 hour. B drives the next 2 hours at 48 km per hour. C drives the next 3 hours at 52 km per hour. They reach the destination exactly after 6 hours. Their mean speed was. This is a very simple sum. We know that average speed or mean speed is total distance by total time. So the distance traveled through A. Since A is only driving for 1 hour, they travel 50 kilometers. Similarly, distance traveled through B equals to 48 into 2, because the speed is 48 km per hour and the duration is 2 hours. So it's 48 into 2, which is 96. Distance traveled through C is 52 into 3, which is 156 kilometer. So now, total distance. What will be the total distance? Total distance is the distance which is traveled by all the three or through all the three, which is 50 plus 96 plus 156, which is 302 kilometer. Total time equals to 6 hours. So mean speed equals to 302 by 6, which is 50 point or 51 by 3 kilometer per hour. You will get 52 by 6, which can be further simplified to 51 by 3 kilometer per hour. Moving on to the next sum. A man can row 13 kilometer upstream or 28 kilometer downstream in 5 hours. We have to find the speed of the stream. These are the options. When we solve this sum, we need to remember the formula for upstream and downstream. Let speed of boat equals to x kilometer per hour. So speed of stream, we assume it as y kilometer per hour. So whenever a boat is moving upstream, since it is moving against the current, the speed will become x minus y kilometer per hour. And while downstream, since it is going with the current, the speed will be x plus y kilometer per hour. So, while going upstream, speed is 13 by 5, which is 2.6 kilometer per hour. This is upstream. And the speed downstream would be 28 by 5, which is 5.6 kilometer per hour. That means, as per the question, x minus y equals to 2.6, which is equation 1, and x plus y equals to 5.6, which is equation 2. So if we subtract the two equations, we will get minus 2y equals to minus 3, or y equals to 1.5 kilometer per hour. That means the speed of stream, which we had taken as y, is coming out as 1.5 kilometer per hour. The next question is, if a man rows at 6 km per hour in still water and at 4.5 km per hour against the current, then what is his speed of rowing along the current? Like the last sum, let speed of boat in still water equals to x kilometer per hour, and let speed of current equals to y kilometer per hour. As per the question, x equals to 6 kilometer per hour, which is the speed of the boat in still water, and x minus y is 4.5 kilometer per hour. Why x minus y is 4.5? Because when he is moving against the current, that is when he is moving upstream, the speed is 4.5 kilometer per hour. So this is equation 1, this is equation 2. If we subtract 1 minus 2, we will get y equals to 1.5 kilometer per hour. That means the speed of the current is 1.5 kilometer per hour. Now the question is, what is the speed of rowing along the current? Along the current, speed of rowing equals to x plus y, because when he is moving along the current, he is moving downstream. So his speed would become 6 plus 1.5, which is 7.5 kilometer per hour. So the option would be option D. The next question is, a man sees a train passing over a 1 kilometer long bridge. The length of the train is half of that of the bridge. If the train clears the bridge in 2 minutes, the speed of the train is, and here are the options. When we are solving this sum, length of bridge, it is given to us as 1 kilometer. Length of bridge equals to 1 kilometer. Length of train is half of that of the bridge, so it's half kilometer. Total length means the length of the bridge plus train. This would be 1.5 kilometer. Now when the train has to clear the bridge, it has to clear its own length and the length of the bridge. Time equals to 2 minutes, which is 2 by 60 hours. So my speed would be distance by time, which is 1.5 by 2 by 60. That is 1.5 into 60 by 2, which will give us 45 kilometer per hour. So the speed will come out as 45 kilometer per hour, which is option B. The next question is, a stream runs at 1 kilometer per hour. A boat goes 35 kilometer upstream and comes back taking a time of 12 hours. The speed of boat in still water is. So while solving this sum, we will assume let the speed of the boat be x kilometer per hour. Let the speed of the boat equals to x kilometer per hour. Since speed of stream that is given as 1 kilometer per hour, so speed upstream would be x minus 1 kilometer per hour, and speed downstream, that is when it is going with the flow of the stream, is x plus 1 kilometer per hour. Now, according to the question, the boat goes 35 kilometer upstream. So the time it will take is 35 by x minus 1, and it comes 35 kilometer downstream as well. So that is 35 by x plus 1, and the total time it takes is 12 hours. So if we now solve it, 35 by x minus 1 plus 35 by x plus 1 equals to 12. So if we equate it, if I take 35 common from here, 1 by x minus 1 plus 1 by x plus 1 equals to 12. That is, x square minus 1 being my LCM equals to, if I write it, 12 by 35. So we will get 2x into 35, let it keep it like this, 12 into x square minus 1. So 12x square minus 70x minus 12 equals to 0. So we get a quadratic equation in the form 12x square minus 70x minus 12 equals to 0. If we simplify this, we'll get 6x square minus 35x minus 6 equals to 0, or 6x square minus 36x plus x minus 6 equals to 0. If we take 6x common, x minus 6 plus 1, x minus 6 equals to 0, or from here we will get x minus 6 into 6x plus 1 equals to 0, or from here we will get the value of x as 6 km per hour, which is option A. So my final answer would be 6 km per hour, or option A. Moving on to the next sum. Two shots were fired from the same place at an interval of 12 minutes, but a person in the train approaching the place hears the second shot 10 minutes after the first. The speed of train, if speed of sound is 330 meter per second, is. So let us take the speed of train as v. Let speed of train equals to v meter per second. Therefore, distance travelled in 10 minutes. So we know distance is speed into time, so v into 10 into 60, converting it into meter per second. Similarly, distance travelled by sound so the combined distance would be 600v plus 330 into 600 meter per second. So this is the combined distance. So the combined distance is found out by adding the distance travelled by the train in 10 minutes and the distance travelled by sound in 10 minutes. If the train would have been static means if the train would have been in its original position, then the person would have heard the sound after 12 minutes. So, distance traveled by sound in 12 minutes would have been 330 into 12 into 60. According to the problem, the combined distance is equal to the distance the sound would have traveled in 12 minutes. So I get 600V equals to 330 into 720 minus 330 into 600, which is 600V equals to 330 if I take common, 720 in minus 600 implies V equals to 330 into 120 by 600, which is 66 meter per second. So the velocity of the train is 66 meter per second. Here the answer would correspond to none of these. That means option. Moving on to the next question. A train starts from station P at 7 am and moves at 60 km per hour towards Q. At 1 pm, another train starts from Q towards P at 80 km per hour. When do the two trains meet if distance between P and Q is 1200 km? So let us draw a rough diagram between P and Q. So the distance is 1200 km. A train starts from P at 7 am and it is moving in this direction, while another train starts from Q at 1 pm, which is moving in the opposite direction. So the first train is 6 hours ahead of the second train. So distance traveled by first train in 6 hours equals to 60 into 6, 360 km. So in the 6 hours between 7 am to 1 pm, the distance that is being travelled by the first train is 360 km. Distance remaining. So it was 1200 km minus 360, which is 840 km. Now at 1 pm, both the train which is running from P to Q and the train from Q to P, they will both ply together. So we will have a scenario for relative speed. And since the trains are coming from opposite directions, their speeds will get added. So we'll have the relative speed as 140 km per hour. So distance is 840 km, relative speed is 140 km per hour. So time taken to meet would be 840 by 140, which will be 6 hours. That means from 1 pm you add another 6 hours. So the trains will meet each other at 7 pm, which is option B. Moving on to the next sum, which is a continuation from the previous sum. A train starts from station P at 7 am and moves at 60 km per hour towards Q. At 1 pm, another train starts from Q towards P at 80 km per hour. When do the two trains meet if distance between P and Q is 1200 km? In the above problem, at what distance from Q do the two trains meet? Now, solution. If we remember what we did in the last numerical, we remember the two trains met after 6 hours. That is, they met at 7 p.m. So in 6 hours, the second train travels 80 into 6, which is 480 kilometers. That means the second train, which is starting from Q, would be moving 480 kilometers. And since in the question it is mentioned at what distance from Q do the trains meet, so the distance at which they meet from Q is 480 kilometers. That means option C.